Good afternoon, good morning, and good evening to all of you. I'm happy to inform you that in today's webinar, we have hundreds of participants. Indeed, it is a webinar that is looked forward by everyone. We have so much to unpack and to learn in today's topic. And together with us are participants, attendees from USA. We have people from Vietnam, from the Philippines, from Malaysia, from India, we have from different parts of Europe. We have also participants from different parts of Africa and as well as from many other locations. And we'd like to thank you all and we welcome you in today's webinar. We will begin very shortly as we just wait for some of our attendees to join in and settle in as we unpack our exciting topic for this afternoon. And again, I'd like to thank you for your presence and for your time joining us and to learn more about this exciting topic that is brought to you by eFeedLink and Evonik. So we'll just wait for a little while for our participants to come in. We are now at about 200 in attendance. Again, for those who just came in, welcome in today's webinar. And thank you for joining in another eFeedLink webinar. My name is Alvin, and I will be your host for today. Before we get started, please allow me to take a little bit of your time to talk about eFeedLink and our services. eFeedLink.com is the most visited feed and livestock industry website. Our species-focused website has dedicated channels covering the latest market news, hot topics, technical articles, industry interviews, event highlights, and company updates in the feed and livestock industry. Livestock and Feed Business Magazine is the preferred magazine for key decision makers from the feed and livestock industry to stay abreast of the emerging market developments, industry happenings, and technologies. Please do subscribe to Livestock and Feed Business at efeedlink.com. And in case you will not receive the print copy, you will receive the digital copy that is sent on a monthly basis. And finally, you can organize webinars and join our future webinars in eFeedLink's Agri-Digital Hub platform, targeted specifically to the livestock and feed industry. Please do visit agrihub.efeedlink.com to view and sign up for our future webinars. A little housekeeping. If you have any questions during the presentation, please type them up into the question box of your Zoom panel, and we will be happy to bring them up during our Q&A session at the end of the presentation. And today, let us together learn on unlocking the benefits of Tributyrin in animal feed. This session features two distinguished speakers who will share their expertise on the critical role of Tributyrin in animal nutrition. Lukas Bauer from Evonik will discuss the essential functions of butyric acid in promoting gut health in animals, highlighting the advantages of Tributyrin compared to other product forms in the market. He will also detail Evonik's innovative testing of Tributyrin release kinetics using a unique poultry gut simulation model, introducing SpeoCare T60 as the leading source of butyric acid aimed at enhancing animal health and performance. Our other speaker, Jojo Wang from University of Sydney and Poultry Research Foundation, will present findings from recent trials that reveal intriguing effects of Tributyrin in specific dietary compositions, showcasing its potential to further optimize animal health and performance. Our first speaker in today's afternoon is Lukas Bauer. Let me tell you a little bit about Lukas. Lukas holds a bachelor's and master's degree in agricultural science with a focus on animal nutrition and animal production from the Technical University in Munich, Germany. He completed his academic training with a doctoral thesis on a newly developed feed additive at the University of Bonn in Germany. Lukas began his professional career in 2017 as a technical support manager in the animal nutrition department of Evonik in Hanau, Germany. And in 2020, he became global technical consultant for Evonik guadinoacetic acid product at Guanamino. Since September 2023, he has been global technical marketing manager for specialty additives product portfolio at Evonik, and his main responsibilities include translating insights from scientific and commercial trials of SpeoCare T60 and other feed additives into practical solutions that improve profitability and sustainability of animal production. And in addition to his work at Evonik, Lukas has gained extensive practical experience in animal production by running a small poultry farm in southern Germany with his family. Without further ado, please help me welcome our first speaker, Lukas Bauer.
So hello, good morning, good afternoon to everyone in the webinar today. So I'm very happy to see so many participants in our webinar, and it shows to me that, of course, we have hit the right topic for today. And I will share now my screen to to present my or to open up my presentation for today. And my topic for today is that we will look into our recently launched, let's say, SpeoCare T60 product, what we have figured out with our science-based in vitro test models, but also with our in vivo trials where we have seen great benefits of our product. So our agenda for today is that I will first go into the butyric acid's mode of action. Yeah, so of course, a lot of you are already well aware of the great benefits of butyric acid, but just to recap on its mode of action again. Then we will look into the, let's say, unique properties of our product, showing you our release and also our physical handling characteristics. In the third point in the agenda, we will look more deeper into our feeding trial results we have received from different regions in different species as well. So we will, in my presentation, we will look into poultry results and also into swine results. In Jojo's presentation, we will look into a specific poultry trial or broiler trial where we have tested in specific diets. And then in the end, we come to the summary and conclusion. So first of all, when we talk about butyric acid, we want to actually explain why or what is the challenge we are targeting with our product. And the challenge we are targeting is a healthy or good gut integrity. So we really need to make sure as animal producers that our animals have a good gut integrity. So why is this so important? Yeah, because antibiotics, stress, pathological conditions, those all disrupt the microbial composition. Microbes, they are responsible for, let's say, short-chain fatty acid production, as we know. And if there's a disruption, we also see that there is a decreased production of key endogenous substances. Among of them is butyric acid. When we see that butyric acid levels are going down, we typically see that we come to a leaky gut situation. So that's what you see on the right side of the slide. So leaky gut means in the end that we have faulty tight junctions, as you see here. So the epithelial cells, they are not close together. With that, we have paracellular transport of nutrients, but also, let's say, transcellular here as well. This relocation or location of bad bacteria, but also viruses into the bloodstream. And you can imagine that this is, of course, leading to inflammation, and that, of course, needs a lot of energy. And in the end, this decreases really the performance of the animal. So by having this leaky gut, we see compromised immune function and also compromised nutrient absorption, and that, of course, leads to economic losses. On the other hand, if we really make sure that we have a good gut integrity, so that our gut barrier function is intact, we see that the gut can really act as an essential immune organ. The gut maintains homeostasis and the overall well-being of the animal. It provides the body with nutrients and sufficient energy, and it supports the pathogen defense, and it enables optimum performance of the animal. So that really leads to profitable production. So in the end, we can say, even if we are doing everything right on the nutritional side, we can still have economic losses if we are not making sure that we have a good gut integrity. So how can we really improve this gut integrity and our overall animal health? Yeah, and I really like to show this slide because it shows that we have different options, of course, when we look into our feed additives. So I hope probiotic products in the market. We have prebiotics, we have phytogenics, we have organic acids, and of course, on the other hand, we have also butyric acid. What we can say about butyric acid is that it's, as you see here, a very well-defined, let's say, molecule, which can really help in a lot of those, let's say, categories or mode of actions. And that's really the good part for, or a good point for butyric acid. It's so well-defined, and that we also have a well-defined mode of action shown in research. And what I also want to mention is that, of course, it's possible to combine butyric acid as a feed additive with other feed additives, for example, probiotics. And I will show a practical example how we can do that also in our feeding trial results. So just a few short facts about butyric acid and tributyrin. So butyric acid, as we all know, is a short-chain fatty acid. It has 4 carbon atoms. Butyric acid is also naturally occurring in the intestine, but here we need to say not really in young animals, yeah, because butyric acid comes from microbial fermentation in the large intestine mainly, and from substrates as starch and lactate. So if we have a very young animal, the, let's say, gut is more or less sterile, as we know. So this, let's say, microbial, let's say, inoculation will only happen after, let's say, a few days. So we can really say in young animals, butyric acid levels are really low. So, and here we need to think about how we can really increase those levels, yeah, especially in the young animals. Nevertheless, also, let's say in major animals, but in let's say all animals, we see that butyric acid is a very important energy source for enterocytes or for epithelial cells. And that's really the main mode of action, that it's really such a good energy source. When we look into the tributyrin, we see we can say that the tributyrin has 3 butyric acid molecules, and those are attached to glycerol. The tributyrin can be produced by esterification, so by connecting the glycerol with the butyric acid molecules. And our product, so our SpeoCare T60, is actually a solid tributyrin. So we convert this liquid tributyrin, so which comes out of the esterification, into a solid form with the use of a silica carrier. The tributyrin itself is odorless, so it's kind of it has a very neutral smell, so very different to the butyric acid. Butyric acid, of course, we all know, is very smelly. It's very hard to stand the smell, and this is the big advantage. Yeah, so by esterification, we can reduce the smell a lot, or even to a neutral smell, and we also have a very stable molecule. So here below you can see, let's say, just a very simplified scheme how the tributyrin molecule looks like. So the glycerol together with the 3 butyric acid molecules. So in as mentioned already, in literature, we have a lot of research about butyric acid because, and even not only in animals, also on the human side, there's more and more research also on butyric acid positive effects. So we have a lot of, let's say, confirmed effects of butyrate to improve animal health and growth performance. And in this slide, I will go through with you quickly what are actually the mode of actions we can see from butyric acid. So first of all, and this was mentioned already, it's a very important energy source for enterocytes. We also see that it can really stimulate cell differentiation and maturation in the intestine. And with that, we have an effect on the intestinal morphology. So that means we have an increased surface area by having, let's say, increased villus height, for example. And that, of course, leads to improved absorption, yeah, if we have a higher surface area for the absorption. In the end, when we have the better absorption, we also see that there is less substrate in the intestinal lumen for microbacteria to grow. And that, of course, changes to a certain extent also the microbiota composition, and is also beneficial in most of the cases because pathogens, of course, they need nutrients as amino acids, for example, as carbohydrates to grow. On the other hand, so when we look here more on the left side now, we also see, and very good confirmation from research, that butyric acid can support intestinal integrity. So what I mentioned in the beginning, the gut integrity. And that's possible due to increased mucus production, because butyric acid is stimulating the goblet cells where mucus is produced. But we also see increased tight junction protein expression. And with that, we have also a reduced tight junction permeability. So that's also what I shown in the beginning. We have less translocation of pathogens or toxins, for example, into the bloodstream. This improvement of gut integrity also has a very good effect on the prevention of inflammation. Yeah, so if we have less translocation into the bloodstream, I mentioned that already, we have less inflammation, and we also see the cytokine expression is also decreased by supplementing butyric acid. So there is also more, so what you see here, putative, so it's not completely confirmed in research, but there is good indication that butyric acid also can modify the hormonal regulation in the intestine. And with that, there might be also improvements in terms of pancreatic secretions, yeah, so enzyme secretions, but also a modification of the mucosa, and also improvements in terms of, let's say, passage rate, yeah, and that would also improve again the nutrient digestibility and absorption, and overall we see the benefits combined really lead to improvement of growth performance. And that's what we will also show in our trial results. So now we come to the next point, so the second point in the agenda. So how do we actually compare our SpeoCare T60 with other products in the market? Of course, you know, we are not the first one with a Tributyrin in the market, but we can really show nicely what are the advantages of our product. And that's what we do now in the second point. So first of all, when we think about how to supplement butyric acid, we need to think about all the different product forms in the market. And here we can really see three main different product forms. So we see salts of butyric acid, so for example, sodium and calcium butyrate. And in this slide, I will explain a little bit what are the release properties of those different product forms. So especially here for the salts of butyric acid, there was already early research indicating that those salt forms of butyric acid are really quickly disappearing in the upper gastrointestinal tract. So if we look into our animals here, so poultry and swine, so basically the butyric acid of those salts is actually already absorbed in the upper gastrointestinal tract. So here, for example, in the proventriculus in the poultry, or here in the stomach of the pigs, yeah. And that's, so to say, not what we want, yeah. So we see that only 1% or less than 1% even from that research could be recovered in the digester of the duodenum. So that means we don't really have the effect of the butyric acid being an energy source for the enterocytes, because all of that butyric acid is already absorbed in the upper gastrointestinal tract, where we actually don't really have the effect on the gut development. Then when we look into the second product class, the coated butyrate products, so we can see mainly those fat-coated calcium butyrates or sodium butyrates in the market. And here we need to say, of course, this fat coating that prevents an early release of the butyric acid. But if the coating is rather, let's say, poor, so that we have a fast release of the butyrate, then of course we have similar situation as with the salts. So too much is already absorbed in the upper gastrointestinal tract and not released in the small intestine or large intestine. And of course, there could be also the opposite, that we have too much coating, so too much fat matrix. And in this case, of course, we could say that the product is animal protected, so not all of the butyric acid is released in the animal. And this could be especially the case in young animals, where the lipase activity is maybe not sufficient to break down this fat matrix around the butyrate salts. Another disadvantage of this product form is that typically the butyric acid content of those products is relatively low because we have the fat matrix. And that's, of course, not what we want. We want to have a high butyric acid content in the product, to have the highest possible amount of active substance in the product. Then when we look into the third category, so here is where the Tributyrin comes into the play. But here we can also say the esterified butyric acid sources, because we not only have the Tributyrin, but also monobutyrin products in the market. But basically, let's say the concept is the same. With the esterification, we see that the molecule is very stable in the upper gastrointestinal tract. So that's also, let's say, can be seen in literature. So we have no release of butyric acid in the upper gastrointestinal tract. However, let's say for us, it was very important to understand if we really have this, let's say, sustained and good release characteristics of our product. So that's why we have conducted our own studies to see if the Tributyrin, so as we expect, is really only cleaved in the small intestine with the lipase, pancreatic lipase, into butyric acid, glycerol, but maybe also even into monobutyrin. And that's what I want to show now. So I want to show you now how we tested this and what kind of in vitro setup we have for this. And I would say this in vitro setup, what Evonik has, is quite unique. So we have really the possibility to simulate gastrointestinal tract of poultry very well with this in vitro model. So you see here the scheme of this model, but I also have a video in the next slide that you can really see how it looks like in reality in the lab. But here in the scheme, you see that we have different vessels, glass vessels, and those different glass vessels, they, let's say, simulate different compartments of the poultry gastrointestinal tract. So in this first compartment here, or in the first glass vessel, we see that this one is simulating the crop, proventriculus, and gizzard, so the upper gastrointestinal tract. The second one is simulating the small intestine, so, or the upper small intestine, so to say the duodenum and jejunum. In the third glass vessel, we have the ileum simulation, and then also in the fourth one, we have cecum, and in the fifth one, we can simulate the colon. However, for our, let's say, research now, when it comes to the release kinetics of our product, it was most important to check how much butyric acid is released in this first compartment and also in the second compartment. And what I also want to mention is that we really have the possibility to include all, let's say, enzymes, which are typically also secreted in the animal, like pepsin, and in the pancreatic juice, we have the lipase and amylases, proteases. We also have bile in that model. let's say, to also have an emulsion of the fatty acids. So that's all possible in that model. And what we did for this test is that we have one, let's say, control feed or basal feed without any additive. And then we have a second, let's say, apparatus. So we have actually in our lab 4 apparatus, or four of those, let's say, models in parallel. And here in this test, we had a second model in parallel, where we had the basal feed plus our SpeoCare T60, where we can then see what is the difference between the control and also our control feed plus the SpeoCare. So here I hope the video plays now very well. So I will just start this video now, and I will explain a little bit in parallel what you see. So it will show you now in 1 minute how this simulation model looks like in the lab. So you see here, as explained before, the different glass vessels, and they are connected to a lot of different tubes. So we have here the possibility to regulate the pH level, and as I said, to include enzymes. We also have the possibility to include microbiota. So I will not go into the details today, but for that we also included to take also samples at different time points to really check different short and fatty acid concentrations as well. That's also one advantage of this model compared to the, let's say, real animal, that we actually have possibility to exclude absorption of nutrients. And with that, we can really see how much of those short chain fatty acids are produced. Because if you would look into a real animal, then of course you always have option, and you might not be able to see from the product. Yeah. So that's really important to mention. So now this video is finished. So I will go to the next slide now. So here on this slide, you see then the results of our test. So in very short, so you see actually that we analyzed the concentration of Tributyrin here in the blue bars. You see here in green the crop and gizzard compartment, and you see that the Tributyrin content is stable. Yeah, so we have no degradation or no cleavage of the Tributyrin in the upper gastrointestinal tract. That's what we could really confirm in our in vitro test here. And when you look now into the, let's say, upper small intestine, or the, I mean, here we even have included ileum. So this is the whole small intestine with different sampling points. And you see actually that very rapidly, there is no, so already with this first sample collection, we have not seen any Tributyrin anymore. So the Tributyrin from our product is really, let's say, rapidly cleaved into dibutyrin first, but also you see already some monobutyrin. And here on the right side, you also see that there is already some butyric acid released, of course, yeah, because when we have the dibutyrin, one butyric acid is already cleaved away, and when we have the monobutyrin, two butyric acid molecules already cleaved away. So immediately we have an increase of the butyric acid concentration when we take the first sample from the duodenum. So the lipase is really, let's say, strong in cleaving at least this first and also third, or the butyric acid on the first and third position. And when you see then in the next sampling points, so the 5th, 6th, and 7th, so we have a gradual decrease of the dibutyrin here in orange, and a gradual increase then in the monobutyrin. So in the end, you see that there is actually most of the esters are in form of the monobutyrin, and only a small percentage is in form of the dibutyrin. So in the end, as a conclusion, we can say we have definitely a strong release of butyric acid, but still, based on our research here, we still have some monobutyrin also in the intestine. And now in the next slide, I want to explain why this is actually beneficial to have butyric acid and monobutyrin from that release. So what I forgot to mention, and I will just quickly go through this slide again. When we talk about this monobutyrin here, we say this is a SN2 monobutyrin. The definition is that the butyric acid is connected to the, let's say, hydroxy group of the glycerol in the middle part, not in the first and third position, so to say. And that's very well known from research that the lipase, pancreatic lipase, rather cleaving the first and third position, it rather stays in the middle position here, or the butyric acid is rather connected here in the middle position in the end. So first, when we look to the left side here on this slide, we actually can talk about what is the effect of butyric acid then as soon we have it released in the intestine. So the butyric acid itself, it's actually not in the, let's say, undissociated form, as we say in the intestinal lumen. It's in a dissociated form. So that means, as you see here, we have a butyrate anion and a proton. And that happens because in the intestinal lumen or in the small intestine, we rather have a neutral pH. And here in this neutral pH, we really have this dissociation of butyric acid. So what is the then the effect of this, let's say, dissociated butyric acid? We see that those protons, they actually lead to a reduction of pH in the intestine, and that's beneficial for some of our beneficial bacteria, so to say. So for example, lactobacillus and also bifidobacteria, they benefit from a change in the micro pH environment. And with that, we also have some effect, of course, on the pathogens like Salmonella and E. coli, for example. On the other hand, when we look into the monobutyrin, we have actually here a more lipophilic, more fat-soluble molecule compared to the butyric acid, or this dissociated butyric acid, we have to say. So this monobutyrin can diffuse across lipid membranes of microbial cells. And that's what's shown here below that text. So as soon as the tributyrin from our product is cleaved into the SN2 monobutyrin, it can go through the lipid bilayer of the bacterial cell membrane. So that's what you see here. So this is the lipid bilayer, how it typically looks like of the bacterial cell membrane. And in the bacterial cell, there are also bacterial lipases, which can then also cleave that monobutyrin further down into the butyric acid. And here we have the same. In the bacterial cell, we typically have a neutral pH. So that butyric acid is again dissociated in butyrate anions and also protons. And that protons again lead to pH reduction, and that really disturbs the metabolic pathways of the bacteria. So that's so to say, we have a effect of dissociated butyrate, but also we have the effect of the monobutyrin, what we see here from our, let's say, release kinetic results of our product. So when we come now to the, let's say, comparison, also based on our results now and also based on the research we see in the literature, we can draw this table here. So here I have the 4 different product forms. So I have the salt form, coated butyrate salts, the alpha monobutyrin. So here actually the difference is that we have the butyrate anion connected at the first position. And this is what we typically see with monobutyrin products in the market. And then we have the tributyrin product form. So what we have in our product. And when we look to the smell, then we see that basically those salt forms, they still have a high butyric acid smell. The coated forms, they have a slightly strong smell as well, depending, of course, on the fat matrix which is used. Those esterified forms, they have the most reduced smell. Then when it comes to the butyrate content, So here we can also see that the Tributyrin shows the highest butyrate content among those product forms. So that's why from an active content perspective, the Tributyrin is really the highest here among those product forms. And when we look into the active molecules, so those salt forms called butyrates, they only have the butyrate as the active molecule, whereas with the Tributyrin, and as mentioned before, we have the butyrate, but also the beta monobutyrin. In the alpha monobutyrins, we have the butyrate and the alpha monobutyrin. So I will come to that difference now. So when it comes to the release properties, based on literature, we see that it has a very fast release here with the salt form already in the upper gastrointestinal tract. The coated products, they are sometimes have an incomplete release, yeah, especially expected in young animals, where we actually need a lot of butyric acid from our understanding. And then when it comes to the alpha monobutyrin, as I mentioned, the pancreatic lipase is actually very strong in cleaving this first butyrate from the glycerol. So here we expect a very fast release in the intestine of the butyrate from the glycerol. So that's why we can question if the monobutyrin is really the active molecule here with those alpha monobutyrins. Whereas with the tributyrin, we see rather sustained release of the butyric acid throughout the intestine, and we still have the monobutyrin as an active molecule. Stability in production process, for example, or during storage, we also see very high stability here for the tributyrin, whereas with the fat-coated product, of course, we also need to consider that with high temperatures in the pelletization process, we might also destroy to a certain extent this fat coating. And antimicrobial effects, when we look into that category, we see actually that with this salt form, again, we can only expect an effect in the upper gastrointestinal tract. With the coated butyrate, it might be rather low, yeah, because we have this relatively low butyrate content and no monobutyrin as a, let's say, degradation product. Then when it comes to the monobutyrin, in my opinion, should be rather stronger than compared to the other two product forms mentioned in the beginning. But tributyrin definitely is stronger when it comes to the antimicrobial effect because of the beta monobutyrin form. And in nutrition to the intestine, based on the sustained release of butyric acid, is also the highest with the tributyrin. So when it comes to the quality and when we compare tributyrin against tributyrin, we need to consider two parts. Yeah, so we need to consider the liquid product quality. So because this is the raw material, of course, to come to a solid product. And here we need to make sure that this liquid product quality is also very good. Yeah, so we have a high purity when it comes to the tributyrin content. So there should be not that much monobutyrin and dibutyrin in that product, of course. So it should be really highly pure in tributyrin. And here we can say our product has more than 99% tributyrin, which is very exceptional when we look into the analysis of other competitor liquid tributyrins. Because when we look at them, typically we see also some kind of color, so yellowish color, brownish color, and that shows also that we have some residues and not the high purity of tributyrin. Whereas in our product, we really see a clear liquid, and that shows no residues and very high purity. When it comes to the solid product quality, so the solid then it comes to the differences in the silica quality. So silica is typically used as a carrier in those solid tributyrins. And this is really decisive, yeah, because the silica in the end determines how good is the handling characteristic of the product. So you can already see here in the pictures that there are also products in the market with a relatively fine, let's say, particle size. Of course, the flowability of those and the dustiness of those products is not favorable. When we look into our product, and I hope you can see it just a little bit, that we have more kind of, let's say, bigger particles definitely and a more granular structure to make sure that we have a good flowability, less dust, but also good mixing homogeneity in the feed. We have also received already a lot of samples from customers when it comes to competitors, and I just want to show you here an example what we have analyzed in our lab about our product and also about competitor products, to really show that we always need to balance, let's say, how we formulate the product, and that we think that we have found a good balance. So first, of course, very important to look at the Tributyrin content. So here we see we have typically we guarantee more than 60%. So in this analysis, we have seen 63% in our product. In those competitor products, we have seen lower than 60%. But there was also one product which showed a high Tributyrin content of 67%, for example. The butyric acid content after hydrolysis. So this is always to check also if the Tributyrin purity is good, or if we have a high Tributyrin purity, because if we have more monobutyrin and dibutyrin in the product, we also see that butyric acid content would be reduced. And we see here in line with the lower Tributyrin content that here those butyric acid contents are also reduced compared to our product. But this one also was then slightly higher than in our product. Then very important for the smell of the product is the butyric acid content. So this is where you really see a difference in the smell. And here we also analyzed the different products. So we see here also that some products here you see in red have a relatively high free butyric acid content. And you also see that when we look into the smell, let's say into the sensory characteristics, this product also had a very strong smell with that free butyric acid content. Then when it comes to the flowability, so we have a grading test here in our lab, and let's say grade 1 would be excellent, or let's say very, very good flowability. 6 is then the worst, let's say, flowability. When we have 4, like seen here, we actually don't have a good flowability already. So that would be already critical to use in automated dosing systems from our perspective. And we see in that product, it has a high Tributyrin content, but from our perspective, this Tributyrin content was too high for the silica carrier. That's why we have seen a bad flowability with big particles as well. So so that's, let's say, the disadvantage. If you put too much Tributyrin on the silica, you will get to let's say, worse handling characteristics. So that's what we don't see in our product. Here we see, even if the Tributyrin content is high, we still see a good flowability. When it comes to the particle size distribution, as mentioned, we need to make sure that we have not too many fine particles, and that's what we unfortunately see in those competitors. Too high fine particles leads to more dust, and also the mixing homogeneity, or let's say the stability of the mix cannot be guaranteed. So we need a good balance of the particle sizes. Of course, also not too large, as we see here in this product. There were too many big particles that would be also not beneficial for the mixing homogeneity. So overall, this showed that we had a good balance of our product, high Tributyrin content, but still very good and beneficial handling characteristics, so easy to use in your automatic dosing systems, for example. So now I want to come to some evidence. So what can we say about, let's say, our product effectiveness? And we have conducted several trials in the meantime, and I want to show a few in broilers, so in challenge conditions, and I also want to show a challenge condition trial in piglets, and then another one under standard conditions in sows. So the first one here is a SpeoCare supplementation trial in HCP-free broiler diets in India. So here we open house, let's say, research facility in India, and with that we can really simulate, let's say, commercial conditions also in India and Asia South, where we also see a lot of those open house farms. This trial was conducted with Vancop 430 very common also in India. And we had 5 treatments. So we had the positive control where HEP was used, negative control, so without HEP usage and without usage of our product. And then we had 3 different treatments with our product and let's say using different supplementation rates to really see what is most beneficial in terms of supplementation rate for the performance. So we used here in this first treatment 500 gram per ton in the starter, 250 gram per ton in the grower phase. In the fourth treat, 500 gram in starter and grower, so that's the difference here, and then 250 gram in the finisher. And then in the last treatment, we doubled the dose and we had 1 kg in the starter, 500 gram in the grower, and 250 gram in the finisher. So those birds were, so to say, also stressed with, let's say, natural heat stress condition, yeah. And we looked into the performance parameters and also into histomorphology, for example, as well. So I will show the, let's say, some results here, not results we have collected. So we look into the performance here of the broilers. So here we see that the negative control without the HEP usage showed here a numerical reduction compared to the positive control. So also the FCR was increased, so showing that, let's say, there was challenge without HEP usage. But when we look into the Tributyrin supplemented birds, we actually see that they even had a higher body weight and similar feed conversion ratio compared to the positive control, and significantly improved compared to the negative control. And here again mentioned there was no HEP used in those treatments here, only the Tributyrin supplemented. So this really showed very good results in terms of these challenging conditions for the Tributyrin supplementation. We don't see a clear, let's say, differentiation in terms of supplementation rates. Of course, we see the more you supplement, the more benefit we tend to see. But basically, yeah, the second treatment with the 500 gram in the starter and grower and 250 gram in the finisher has shown to be quite beneficial in these conditions. The carcass yield or the carcass traits of the broilers were also improved quite significantly, in line with the body weight results. So we see a increased carcass yield, significantly improved compared to the negative control, but even also compared to the let's say the breast meat yield was even increased significantly compared to the positive control, and really showing the positive effects of the Tributyrin. We also looked into the, let's say, why do we see those results? And one part, of course, is the improvement of histomorphology. So as explained in the beginning, butyric acid is a very good energy source for enterocytes, and that's what we see here. So we really see improved villus higher in the bars compared to the positive control also. So HEP is really not helping for the histomorphology based on this research here. So we even see higher villus height in the negative control. And still we see here with the highest Tributyrin supplementation, we see the most benefits for the villus height and also villus height to crib depth ratio. So yeah, that was kind of showing that with increased supplementation rate, and maybe if you have more challenge, then this might be even beneficial to use more of the product. We also did an economical evaluation of this trial, and here we see also, based on what I already said, this T2 with the 500 gram in the starter and grower and 250 gram in the finisher was most economical. and showed really very attractive return on investment compared to the positive control, not compared to the negative control. So then I want to come to the next trial. So here we have used a research facility with more controlled environment. So there was no heat stress condition. However, in this trial, we have used dextran sodium sulfate challenge. And this dextran sodium sulfate challenge is actually provoking enteric inflammation in the intestine. So so with that challenge model, we wanted to see if we really can improve inflammation in the gastrointestinal tract by using the Tributyrin, by improving the gut integrity. So what we had in this trial was also that we had 5 treatments, a positive control, so the basal diet without any challenge, then a negative control, basal diet without the usage, with the challenge with dextran sodium sulfate, but no additive. And then we had different supplementation rates of our product, so 1 kilogram per ton of feed and 500 gram per ton of feed. And then in this test also we used another Tributyrin product in the market with similar handling characteristics but reduced Tributyrin content compared to our product, to see if really, let's say, the difference in the active content of butyric acid can make a difference in the growth performance. So here you see how we applied the challenge model. So you see that we have diet changes here at day 8, and at day 8 we also had the start of the first challenge period. So from for 5 days, the birds in the challenged groups, they were oral gavaged by dextran sodium sulfate solution. And then at day 13, so after this 5-day period, we took samples also to look into the intestinal histology, and also body weight and also feed intake was measured. They had this recovery period from day 13 to day 21. So again, here samples were taken, and although body weight was measured and also feed intake was measured. And after that, another 5-day challenge period was implemented here, again with this daily oral gavage of the dextran sodium sulfate solution. And then after this 5-day challenge, again, we took samples and looked at the body weight, feed intake. And then after this last recovery period, there was another body weight and feed intake measurement. So what we see here in terms of body weight results, so in a table form, you see the numbers, and here in the graph, you see the relative performance or relative body weight development of the broilers compared to the negative control. So with the DSS challenge, but without the additive. So this is set at 100%, the negative control. So we see basically so day 1, of course, the body weights were equalized among the groups. So we see no significant difference. At day 8, we already see a significant difference. So even without challenge, but in those young birds, we have seen a positive benefit by supplementing the 1 kg per ton of feed. So we see 14 gram body weight increase compared to the negative control here, but also, of course, even some numerical difference to the other control, where we had also no challenge up to that point. Then after this first challenge period, it was we could not see any significant differences anymore, but at least we still see the 10 gram body weight difference here at day 13 from the, let's say, Tributyrin supplemented groups and the 2 control groups. Only at day 21, we see again a significant, let's say, improvement of 100 gram now compared to the negative control. So we see 37 gram body weight improvement compared to the negative control. and even more improved at day 26. So after the second challenge period, we see even 60 gram body weight difference compared to the negative control. And so these recovery periods, they always brought back again the performance. So there was kind of a compensation in that recovery periods of the challenged birds without additive. So that's also showed that it was maybe not the harshest challenge with the DSS, but still we see specifically for the young chicks, it was very beneficial when we look here at those three Tributyrin groups, that we have a beneficial effect on the body weight development. When we now look into the difference of our, let's say, product and the benchmark or the other Tributyrin product, we see no significant differences, but what we can see is that we always see numerically at least, there is a lower number with this competitor. And this also shows that, of course, we don't see the significant, let's say, difference, but at least we see numerically and quite relevant differences when we compare the different products and the different, let's say, Tributyrin contents. So it's very important also when we consider the performance to look at the Tributyrin content of the product. When we look into the feed conversion ratio, then we also see specifically at day 8 that we had a numerically very high improvement from this 1 kg per ton group supplemented birds compared to the negative control. At day 13, after the first challenge period, we see then a significant improvement of this 1 kg treatment compared to the negative control. But with those recovery periods, we couldn't see the difference anymore. And when we now look also here into the histomorphology data, we see a very similar, let's say, pattern compared to the trial in India. We really see that the Tributyrin treatments, they increased, so to say, the villus height compared to the negative control. So this DSS challenge really decreased the villus height. So in all, let's say, at all sampling points. And also the villus height to grip depth ratio was impacted by the dextran sodium sulfate. So we see here this drop in the villus height to grip depth ratio, but with the Tributyrin supplemented birds, we can see that there was a compensation up to the positive control level. So now we switch from poultry to swine, and now we look into the first trial here conducted in Vietnam with HEP-free piglet diets. And here the idea was to combine our product, our Tributyrin product, SpeoCare T60, also with one of our probiotic products, Gut Plus, and to see if there is a beneficial effect on combining those, probiotic and Tributyrin. So in this trial, we used weaned piglets. Initial weight was 5.9 kg, and we had the positive control, so with HEP usage, no additive, negative control. So positive control diet without the HEP and no additive. And then the SpeoCare treatment, so where we used 1.5 kilogram per ton of feed in the pre-starter phase and 1.2 kilogram per ton of feed in the starter phase. And then the idea was to create another treatment with the Tributyrin and the Gut Plus, let's say with a similar cost of supplementation. Yeah. So basically the cost of the diets was similar between treatment 3 and 4. The only difference was really that we combined the Tributyrin with the probiotic. So when we look here also into the results, we see that, let's say at day 21 of age, so we see that the body weights were equalized, so no difference. And then into the day 21, into the trial period, at day 42 of age, we see already that there was a significant drop of body weight in the negative control, so without HEP. And we see that in the treatments with Tributyrin and the Tributyrin plus the probiotic, we see results in between the HEP diet and also the negative control diet. So to a certain extent, the Tributyrin and also the Tributyrin plus the probiotic were able to compensate for that drop. And that's actually exactly the same pattern we see at day 36, but here numerically even a higher differentiation, and also significantly we see the drop of body weight, and we see, let's say at least numerically, that the combination of probiotic and Tributyrin numerically worked slightly better than just the Tributyrin alone. And then in the feed conversion ratio numbers, we even see that let's say a stronger differentiation of the results. So here we see that the overall um, without HEP we see around 17 points increase of FCR, and with the Tributyrin, but also even more with the combination of probiotic and the Tributyrin, we could compensate for that increase of FCR, and we were close numerically, already close to the HEP diet. So that really showed that the combination of probiotic and Tributyrin is also beneficial when, let's say, looking at the same supplementation cost. Yeah. Diarrhea incidence was also one measurement, and here we also see, as expected, that in the negative control there was the highest diarrhea incidence, and with the supplementation of Tributyrin and Tributyrin plus probiotic, we see an improvement of diarrhea incidence, but not at the level of the HEP in this trial, and the same with the fecal score. So now I will come to the last topic. So the Tributyrin SpeoCare T60 supplementation in sow diets, and this trial was conducted in Denmark. So here with the sows, of course, you know, it's very difficult to implement those challenge conditions. So that's why this was really under normal conditions, even very clean conditions. This trial was conducted. And in this trial, we had 45 sows per treatment. So different varieties, yeah. So it also shows that we had not, let's say, that we had, of course, quite some, let's say, animal to animal difference, yeah, in terms of performance in the treatments. So of course, not very easy always to get those significant results in the sow trials with a lower number of animals and also higher animal to animal differences. So in this trial, we started with the data collection and also with the supplementation of the Tributyrin 21 days before farrowing, so 3 weeks before farrowing, and then also 26 days into lactation. So total trial period was 47 days. Tributyrin was supplemented with 1 kilogram per ton. And then we see here the first result. So there was no, let's say, difference in born alive piglets, no difference in stillborn or piglets. When we look into the weaned piglets, we see a numerical improvement for the Tributyrin supplemented sows. And that's also what we see here in the pre-weaning mortality of the piglets. So 24% reduction in the pre-weaning mortality. Yeah, it was not possible to show the significant difference, but still the numerical or relative difference was relatively high. When we look into and this was the result which really was the most significant here in terms of p-value, to see that we had around 5 kg of improved litter weight gain with let's say from the sows which were supplemented with the SpeoCare. So 6% increase of litter weight gain. And then we also looked into the, let's say, some biomarkers or some reasons why we actually see this improved litter weight gain and reduced pre-weaning mortality. So first we see here for the sows that we had reduced TNF alpha, also here relatively high, but not significant reduction of TNF alpha, also showing that inflammation was reduced to a certain extent in the sows. And that, of course, means that there's more energy in the end for milk production. And that, of course, milk production or more energy for milk production can then be, let's say, yeah, transferred into higher litter weight gain. On the oxidative stress, we have not seen any effect. However, another interesting result is that when we measure the Brix percentage in the colostrum, which is an indication for the immunoglobulin content of the colostrum, we see that the Brix percentage in the colostrum of the SpeoCare supplemented sows was numerically higher. So also then indicating this higher immunoglobulin content, and could be one reason at least for the reduced pre-weaning mortality of the piglets, because they had a better passive immunity, for example. So also, let's say, even we have not seen always the significant effects, taking into account those numerical improvements, we already see a very attractive return on investment by supplementing the sows with our product. And yeah, so this might be very important to consider for you, also to think about how can we improve nutrient absorption of sows, and here the Tributyrin might be a very good product to improve that. So now I will come to the last point, and I see that the time is moving forward. So what are in general, or in summary, our product properties? So we have more than 60% Tributyrin content. Our supplementation rate recommendations so far are the following. So for broilers, I mean, even for turkeys, it's relevant. So we would consider supplementation rates in the range of 500 gram per ton. We would always suggest to have a higher supplementation rate in the starter phase. So at least 500 gram in the starter phase, and then in the grower and finisher phase, it can be also reduced. In the layer and breeder side, I have not presented data today, but first trials also indicate that 500 gram per ton of feed might be a good supplementation rate to increase hatchability, but also to improve eggshell quality, for example, in layers. Piglets, as demonstrated, we have seen that 1 kilogram per ton of feed, especially when the Tributyrin is combined with a probiotic, can be very beneficial for piglet or weaned piglet growth performance. And in the sows, we have demonstrated that 1 kilogram per ton of feed is a very beneficial supplementation rate to increase litter weight gain. So in summary, want to show here what we have discussed today. So our product, the Tributyrin SpeoCare T60, shows excellent butyrate concentration, very high Tributyrin content, and also the release kinetics really show beneficial sustained release in the intestine. It's a very good gut integrity enhancer. So if you think about gut integrity, how you can improve that, please consider also butyric acid always, or Tributyrin in a product form. And in the end, this can really improve profitability of your operations, and it shows the positive effects on health and performance. So why choose us as a supplier? Because we can show that we have a leading quality of our product. We have an excellent supply security. We can really help you with, let's say, nutritional consulting to check your, let's say, optimal supplementation rate, to see if we can also help, for example, on the amino acids levels. Yeah, we understand us as a gut solution partner, so we not only want to provide only one product, we actually want to understand together with you how we can, let's say, combine products like probiotics and Tributyrin, for example, to give you the broadest range of safety, so to say, for animal health. And we always invest also in research and innovation, as you have seen. So we really try to understand very well what is the best supplementation rate for your diet, what is the best feed additive to use in your specific situation. And with that, we can really help you to optimize the profitability in the end. So why choose SpeoCare T60? I mean, I will not go through all the points. I think we have really shown with data that we have excellent flowability and stability, slightly very reduced smell. It's perfect for automatic dosing because of the good flowability, and it has an optimal mixability because of the very beneficial particle size distribution, and it's stable during feed processing. So we have also data showing that the Tributyrin will be not destroyed in the pelletization process, for example. So overall benefits are gut integrity, villus growth and nutrient absorption, regulation of inflammation and immune response, and antimicrobial effects in the intestine. In the poultry, we have seen improvements of feed conversion ratio, body weight gain in broilers now today, but in turkeys we expect the same. We have also seen our first indications that hatchability, fertility can be improved, so more marketable day-old chicks. In layers, we really see the benefit for eggshell quality, especially in late-laying hens, and inhibition of salmonella. In swine, we have seen also, similar to the broilers, improvement of feed conversion ratio, body weight gain in piglets, improvements, control of post-weaning diarrhea in piglets reduced. So that's what I forgot to mention, and I did not show that. In the sow trial, we have also seen that there was a tendency for reduced back fat loss and body weight loss as well in the sows. And that also is an indication that we can expect an increased fertility in the next reproduction period, and also the reduced mortality and higher weaning weight of suckling piglets. So with that, I want to end my presentation for today, and later on we will have the possibility also to discuss about your questions. But now I will hand over to our guest speaker, Jojo, to present more in detail how Tributyrin can be also used in low protein diets under specific diet compositions.
Thank you, Lucas, for the very insightful presentation. And would like to introduce our next speaker in today's webinar. Our next speaker is Jojo Wang. Jojo is a PhD candidate at the University of Sydney and Poultry Research Foundation, specializing in reduced protein diets and digestive dynamics of nutrients. She completed her master's degree in Shizhe University in China, supported by China National First Class Scholarship. Her research focused on enhancing growth performance and productivity in sheep using flavonoids extracted from locally grown alfalfa. Prior to commencing her PhD, she spent 7 years in the feed additive industry, gaining valuable experience in providing solutions to feed mills and farms. With extensive experience in poultry nutrition, research, and at research institutes and in technical management within the industry, she is passionate about bridging science and practice to support innovative and evidence-based nutritional strategies. Please help me welcome our next speaker in today's webinar, Jojo Wang.
Hello, everyone. I will replace the current share with my screen. Hi, can you see my screen and me? And hello, everyone. My name is Wang Menju, and you can call me Jojo. Today, I'm very honored to share the topic on behalf of our entire team. And the topic is about Tributyrin improves the growth performance of broilers fed local protein diet based on high core protein weight. This study is collaborated with Evonik. Before we dive into more details, the first question is why choose the local protein diet? The local protein diet has been shown to reduce the dependence on one single protein source and help mitigate the nitrogen and ammonia emissions, and thereby decreasing the nitrogen pollution. And additionally, lowering dietary core protein can enhance animal welfare by improving litter quality and reducing the breast and foot population and improve the litter quality. However, the key challenge is how to maintain the growth performance in the local protein diet, especially in the weight-based formulations. A classic experiment was conducted by Dr. Peter Crystal 4 years ago, and in this study, he gradually reduced the dietary core protein in both maize-based and wheat-based diet. When the dietary core protein was reduced by 3%, the growth performance remained in both wheat-based and maize-based diet. However, with another 3% of dietary core protein reduced, the outcomes diverged. The growth performance was maintained in the maize-based diet, but significantly compromised in the wheat-based diet. This was both in terms of the body weight gain and the FCR. This highlights a long-standing challenge in the poultry nutrition, where the maize-based diet are more conducive to core protein reduction than wheat-based diet. Or in another word, maintaining the growth performance becomes more difficult when we're formulating the local protein diet based on weight. To understand why growth performance is compromised when dietary core protein is reduced, we need to consider some key biological factors. The intestine itself consumes around 20% of dietary energy, and the primary source is glucose, and the secondly comes from the amino acids, especially the glutamine. And importantly, the transport of both glucose and amino acids into the enterocytes is sodium dependent. This means they compete for sodium to facilitate their transport. And in this figure, the green ball represents sodium, and the red one represents the glucose. The blue one represents the amino acids. In a sense, this competition may play a critical role in changing the digestive dynamics of energy for enterocytes. So what is happening when we reduce the dietary core protein? This is the standard core protein diet, what it's like in the gut. And when we reduce the dietary core protein, the inclusion of both grains and non-amino acids increases to meet the energy requirement and the ideal amino acids requirements following the least cost formulation principle. The non-amino acids refers to the crystalline amino acids, which is not protein bound, unlike those found in the grains or protein meals. Wheat naturally contains a higher protein than maize. As a result, when we formulated the local protein diet, the required increase in both grain and non-amino acids is higher in wheat-based diet than in maize-based diet. This was evident in the study we mentioned earlier, where the inclusion rate of grain was 4% higher, and the number of amino acids inclusion rate was 28% higher in wheat-based than in maize-based diet. And consequently, the competition for the sodium between glucose and amino acids in the intestine becomes more intense in wheat-based local protein diet. Beyond the competition for sodium between the glucose and amino acids, the characteristics of starch also plays an important role. Although the diet in wheat-based diet and maize-based diet, they are isoenergetic and isonitrogenous. The digestive dynamics of glucose differ from the wheat and maize. Both in vitro and in vivo data show that the starch from wheat is digested much rapidly than starch from maize. So as a result, the more amino acids are catabolized in the enterocytes as energy substrates in wheat-based diet. This increased catabolism of amino acids means the fewer amino acids enter the portal system, reducing their availability for protein synthesis. Therefore, our first hypothesis for the compromised growth performance is that the increased energy expense by the amino acids in the intestine. The second hypothesis about the compromised growth performance in local protein wheat-based diet is relates to the impact of anti-nutritive factors in wheat on gut health. So many individuals, they are sensitive to the wheat-based food, primarily due to the gluten in it. And the gluten makes up 80 to 85 of the wheat protein, and with the gliadin accounting for about 40% of gluten. Gliadin is known to impair the gut barrier function almost immediately by reducing the transepithelial resistance and increasing intestinal permeability to the small molecules. This increased permeability can lead to poor nutrition absorption, and therefore our second hypothesis for the reduced performance is involved the histomorphological changes, specifically the adverse impact of gluten on gut integrity. So the first hypothesis concerns the energy expenditure of amino acids in the small intestine, while the second one relates to the increase the intestinal permeability. Therefore, in theory, if a strategy can, one, supply the energy source to the enterocytes, two, reduce the intestinal permeability, or ideally both, it could improve the feasibility of a local protein wheat-based diet. So the objective of this study is to investigate whether the Tributyrin could restore the growth performance in high-protein wheat-based local protein diet. In this study, 200 raw mixed gender broilers was randomly allocated into 4 treatment, with 10 replicates for treatment and 5 birds per replicate. The diets were local protein diet containing 80.5% in grower stage and 17.5% in finish stage. It was a 2x2 factorial arrangement study. One factor was the weight tab, high core protein weight, which includes 15.3% protein in the weight, and the local protein weight, which includes 10.7% core protein in the weight per se. And the other factor was with all the Tributyrin supplementation at an inclusion rate of 500 grams per ton. You may have a question why we use the same grain, differing in core protein content in the grain itself. We observed the different response in weight-based and mixed-based reduced core protein diet, and we assume that the altered digestive dynamics of the starch and the non-amino acids, which is caused by the differences in protein content in the wheat or maize, it is the root of the compromised growth performance. However, there may be some confounding factors from the grain itself influencing these responses. Compared to the local protein weight, the high core protein weight result in 10% of a higher inclusion of weight, and the soybean meal was reduced by 19%. The number of amino acids was higher by 17%. All this difference could be attributed to the core protein content in the wheat itself. In the grower stage, there were an interactive effect on body weight gain and FCR. In high core protein weight-based diet, inclusion of Tributyrin increased the body weight gain by 7%, and the FCR was improved by 8.4%. When the birds were fed local protein weight, there was no difference with or without the supplementation of Tributyrin. The result in the grower stage indicate that the inclusion of Tributyrin could restore the growth performance in local protein diet based on high core protein weight. In the finish stage, there was an interactive effect on body weight gain, feed intake, and FCR. When the birds fed high core protein weight-based diet, the inclusion of Tributyrin increased the body weight gain by 50%. Feed intake was increased by 36%, and FCR again increased by improved by 18%. However, when the birds fed with a local protein weight-based diet, the inclusion of Tributyrin did not make a difference. In the overall stage, there was an interactive effect between the weight and the Tributyrin. When birds fed high core protein weight-based diet, the inclusion of Tributyrin increased the body weight gain by 26%, and feed intake was increased by 12%. FCR was improved by 11%. There was no difference between the with and without Tributyrin when birds were fed local protein weight-based diet. The result of overall performance indicate that the beneficial impact of Tributyrin was significant. We also measured the gizzard pH at 36 days post-hatch. When the birds without a supplement of Tributyrin, the birds fed with the high core protein weight has a 16% lower pH than the birds fed local protein weight. Although it was not statistically significant, the supplementation of Tributyrin when birds fed a high core protein weight restored the pH by 11%. Furthermore, there was a significant negative correlation between gizzard pH and FCR within the pH range observed in this study. Specifically, with the range of the pH in this study, a higher gizzard pH was associated with a better FCR. So why the pH is important in local protein diet and why it is negatively correlated in this study with the FCR? As we mentioned earlier, local protein diet amplified the competition between the glucose and amino acids for sodium, and which is the essential for the sodium-dependent transporter. This transporter moved the glucose and the amino acids from the lumen gut side to enterocytes or the portal system, and the sodium is required to trigger this process. To maintain the osmotic balance, the chloride ion accompany sodium during this translocation. This chloride ion originally from the HCl secreted by stomach, and as the chloride ions ran away, the hydrogen ions were left behind in the lumen site, leading to a decreased pH in the gut. So in short, a lower gut pH may indicate amplified competition between glucose and amino acids for sodium, and increased amino acids catabolism in enterocytes, which is more pronounced in weight-based local protein diet. This may explain the observed negative correlation between pH and FCR. Here is the nutrient utilization result. Nitrogen retention was 9.4% higher when we supplement Tributyrin when the birds fed a high-protein weight-based diet. However, there was no difference when the birds fed a low-protein weight-based diet between with and without supplementation of Tributyrin. This may indicate more amino acids are available for protein synthesis when Tributyrin is supplemented in the high-protein weight-based diet. We proposed the first hypothesis. The amino acids are used as a fuel substrate in the enterocytes. If another substrate can replace amino acids as an energy source, it could spare amino acids for the protein synthesis. It seems Tributyrin works. Tributyrin has been shown to serve as an energy source for enterocytes and colonocytes, undergoing the rapidly oxidation to generate fuel for the enterocytes after they transported from the lumen into the cells. And at the physiological pH, butyrate requires a carrier-mediated entry across the epithelial cell through the MCT transporter. Study has shown that MCT transporter expression can be upregulated following the Tributyrin treatment. In a summary, the Tributyrin may provide an energy source for enterocytes in the small intestine, thereby sparing amino acids for protein synthesis in this study. The gut health promoting function of Tributyrin is well researched and well documented, and a key area of the focus is its role in maintaining the gut integrity. It's already told a lot by Lukas, and often it evaluated by the tight junction protein and mucin in both the biological and the challenge module. One human study demonstrated that the butyrate significantly stimulates the expression of mucin 2, the primary mucin secreted by the epithelial cells to protect the gut integrity. And another study is a challenge study induced by the ethanol, and we observed also observed the reduced expression of tight junction protein. However, the supplementation with Tributyrin was able to restore their expression and this challenge module. More relevantly, a study in broilers confirmed that Tributyrin supplementation in broiler can upregulate the expression of tight junction proteins, supported its role in enhancing the gut barrier function in chicken. From the result of our study, we can see the higher inclusion of weight and the number of amino acids could be the reason for compromised growth performance of birds fed a high-protein weight. And the Tributyrin could restore the compromised growth performance in local protein diet based on high-protein weight, possibly by sparing amino acids as energy substrate in the gut. More upcoming results on digestibility will tell us the story about the Tributyrin impact on the gut health in local protein diet. Thanks for the support from all the institutions of the team, especially the Evonik and the Poultry Research Foundation. And without their support, we can do nothing on this study. Thanks for your listening, and any question is welcome.
Thank you, Jojo, for that wonderful presentation. And now let us take this time to answer the questions from our attendees with a panel discussion. We have a number of them, and we wanted to, of course, give them an answer. And yes, all right, I will just dive into it with the first question. This question is for Lucas, but Jojo, you're free to add your insights as well. The first question is this: why is butyric acid important for gut integrity?
So for gut integrity is so important because I would say the first very important function it has, it's the very good energy source for the enterocytes. So that means enterocytes, they will, let's say, use the butyric acid, and via beta oxidation, they produce ATP. And with that ATP energy, so to say, they can grow, they can differentiate, no? And this is very important because we know epithelial cells, they actually die, so to say, every 4 days. So they have really long, short life. So we really need to have that energy to really, let's say, have this growth and also replenishment, so to say, of cells all the time. Another thing is that butyric acid has shown, as mentioned in my presentation, a very good effect on the mucus production in the intestine. So let's see, when we have more butyric acid or increased butyric acid concentration, more mucus is produced, and that mucus is very beneficial for protecting the epithelial cells from physical, but also from physical stress, yeah, like the feed digester, which is passing by, but also from pathogens and toxins, yeah. And I would say the last point I want to mention is the effect on the tight junction proteins. So here we also see with increased butyric acid concentration, we have an increased expression of those tight junction proteins, including occludin, for example, is maybe the most known one. And yeah, so with that, we really increase the gut barrier function, with the butyric acid.
Yeah, thank you. Lucas, I'm not sure if Jojo wants to add or.
I totally agree with Lucas. As we can see, including the tight junction, the result from the other studies we have in my slides, the expression of the transporter is not upregulated no matter the humans or rats or chickens. It's all proved.
Yeah, thank you, Jojo. This next question, I believe, was covered by Lucas's presentation, but I also just wanted to stress out since the attendee is asking. It's asking how much amount of butyric acid can be added in poultry diet in different forms.
In the different forms, let's say, I mean, you have seen our recommended dosages. I mean, you see, the more challenging the condition, the more interesting it might be also to increase the dose a little bit, because we really see the effects in the villus height, no, for example, so in increasing the surface area, and then with that improve the nutrient absorption. So for example, 1 kg per ton of feed would be already a relatively high dosage in broilers, I would say. In piglets, we have seen that actually more than 1 kg is also beneficial, yeah, or is even more beneficial. So it really depends on the species. But I would say regularly it's between 0.5 and 1.5 kg per ton of feed, what we should consider in the different species. When it comes to the other product forms, of course, we can say, first of all, we should always compare on the butyric acid level. Yeah, so what we dose. So for example, in our product, we have more than 50% butyric acid. So if you compare that, for example, with some fat-coated products, they have sometimes only, let me think, I would say they have sometimes only around a little bit more than 20% of butyric acid. So that means you would actually need to double the dose compared to the tributyrin. And I think there are even trials in literature showing that a double dose of the fat protected product has the same effect as half of the dose of the tributyrin. So it really needs to be considered on the butyric acid level. But of course, the release properties of the product also comes into the picture. So if you have too much release in the upper gastrointestinal tract, as we see with the salt forms, then of course you can also not expect the effect on the gut integrity. So with the salt forms, it might be rather interesting to use them as a kind of let's say pH reducer to a certain extent in the upper gastrointestinal tract. But for this, actually, there are other products which might be more beneficial, which has a higher capability of reducing pH, like for example, the much shorter fatty acids like formic acid is one example, has a stronger acidifying effect in the gut, so to say. But of course, the formic acid doesn't have the beneficial effects on the gut development, or it's not a, let's say, per se energy source for enterocytes. Yeah. So that would be my suggestion. Yeah.
Thank you, Lucas. We'll proceed to the next question, which attendees are asking when comparing tributyrin and monobutyrin, which is also available commercially. So, what are the benefits of feeding tributyrin versus monobutyrin?
Okay. Yeah, I think so. This question seems to be easy, but it's not so easy. So it's really we need to go into the technical details to really understand the difference. So I really tried to show in my presentation a little bit the difference, but maybe it was not so clear. So what we see with the monobutyrin products in the market is that most of the butyric acid is actually cleaved to the first and to the third position at the glycerol. So I'm not sure if you see my hand very well, but if you can imagine, those are the three butyric acids, so to say, connected to the glycerol. In the monobutyrin, we actually have it at the first position, or so to say in the third position then. No? So so there is really little, let's say, amount in this middle position. And what we know from the pancreatic lipase is that it cleaves really well the butyric acid in the first and in the third position, because it can really, let's say, because of the form of the molecule, it's easier for the lipase to go to cleave out the first and the third position, not that much the middle position. And that means when we have now those SN1-3 monobutyrins as products in the market, those monobutyrins are very rapidly cleaved as soon as the pancreatic lipase is there in the intestine. No? So that means the monobutyrin is not there as an active molecule in the intestine because it's already cleaved into glycerol and butyric acid. With the tributyrin, we see that we have this SN2 monobutyrin, as we say, as a result from the first cleavage, so to say. And then this SN2 monobutyrin can really diffuse into bacterial cells and then destroy or disrupt the metabolism of the bacterial cell. So that's why we always say with the tributyrin, you actually don't have only the butyrate as an active molecule, you also have the monobutyrin, the beta or SN2 monobutyrin as an active molecule. And that's the difference. Yeah, it's a very long answer, but it's really, let's say, we really need to go into the technical details to understand the difference. Yeah.
Thank you, Lucas. This next question will probably our also last question due to the amount of time that we have left for this webinar. The question is this: what are the most important energy sources for enterocytes next to butyric acid?
Maybe Jojo can answer this. I guess she knows very well.
Thank you. And normally in the enterocytes, especially the jejunum and ileum, the first one is a glutamate acid is the first choice of them, and the second one is the glucose. And in our previous published paper, we also give insight like we more prefer the birds use more from the glucose because the amino acids can participate in the protein synthesis. So that's our wish. We hope it can have more amino acids go to the protein synthesis and give more higher body weight. So that's how we provide. That's also we provide the Tributyrin to the local protein diet, and then it can spare the amino acids as the internal energy substrates. Because when we reduce the local protein diet, especially the weight, it goes through the enterocytes very quick. So the enterocytes can't catch it. I lost my food, so I don't have choice. So I only can use amino acids. In this scenario, we really want to release the amino acids to the body. So the Tributyrin really works. Yeah, that will be my answer.
And I think maybe one addition, I think in colonocytes, so let's say in a large intestine, actually research shows that even in there, the butyric acid is the most preferred energy source. So so maybe not so relevant for the broilers, but in pigs, of course, if we can really increase the butyric acid concentration in the large intestine, then we really have that positive effects on the colonocytes, for example, for mineral absorption, which takes place there mainly, but also in laying hens, for example, that we understand as the main mode of action behind the improved eggshell quality is that we can really improve the colonocyte growth or the surface area to absorb nutrients. And here we see that the mineral absorption mainly takes place, and to have this, let's say, nice effect on calcium absorption, for example, as well.
Right. Thank you, speakers. And it seems like that is all the time that we have for today's webinar. And for questions that we have not answered live during this Q&A, we will be providing and forwarding them to our speakers, and the responses will be emailed to you accordingly. And to our attendees, fret not, we will send you the recording of this webinar so you can review the presentation and the information, the data that is presented by our speakers. And once again, we would like to thank our distinguished speakers this afternoon, Lukas Bauer and Jojo Wang, for sharing their knowledge in today's topic. And of course, to Evonik for bringing us this wonderful webinar. Lastly, to our attendees, we appreciate you being here and we welcome your feedback on this webinar. And please do visit IFIDLink's Agri Digital Hub for more industry relevant presentations. So once again, thank you for joining us, and we would love to see you in our future webinars. Thank you.
Thank you. Thanks for your attention and attendance. See you. Bye.
Thank you.